Jarquin. My ID is A01665446, and this is about analysis of electrical circuits. Here we have a case that involves various meshes and a supermesh. What is a supermesh? A supermesh is a special situation in which two meshes are interacting with each other because they have an independent source between two of them. So this is going to define how our supermesh is going to be defined. In this case, we have mesh 1, 2, 3, and 4. So 2 and 3 are going to be interacting with each other. So in this case, we need to be working with Kirchhoff's law of voltage. It states that the sum of all the voltages is going to be equal to 0. And Ohm's law that states that voltage equals to resistance times current. Current defined as I. So in that same line, we're going to be defining I in each one of those meshes. First, we have I1, I2, I3, and I4. The way that the current is stated here is just a proposal, because further we're going to realize if that direction is actually the real direction in which the current is behaving. So first we need to apply Kirchhoff's law of voltage to each one of these meshes and a special interaction with the supermesh. So the first one is going to be minus 5 voltages because of how the polarization works here. If this was reversed, we would be working with a positive 5 voltages. So minus 5 voltages plus 30 ohms times I1 because it is the current going through this mesh plus 45 ohms times 1 minus times 2. Why is this happening? This is happening because this one right here is a resistance, a branch that is working with two currents at the same time. In this case, it is working with I1, and in this case, it is working with I2. So because we are working right now with the side of I1, we're going to say that this one is positive and this one is negative. So we're going to keep this one for reference in future occasions. And well, yeah, we got this one, so it's going to be equal to 0 because of this. Now we're going to be working with the supermesh. First, we're going to be working with mesh 1. Now, supermesh. Supermesh is going to be stated as it follows: 45 ohms times I2, because now we're working with the I2 side, so we're going to say that that one's positive, minus I1, plus this resistance that is 44 ohms times 2 minus times 4. And okay, now we are finished with this side of the mesh, but this is a super mesh, so we need to really focus on the other branches of this one, this other mesh, with another current. Now we're working with R4, which is 44 ohms times I3. Now equals to 0 because of this. And now we'll be working with this current I4, so this is going to be mesh number 4. And mesh number 4 works with resistance that is 54 ohms times I4 minus I3, because this case is exactly this case, just that at an angle of 90 degrees. So yeah, plus 6 voltages because we're entering positive and with a negative, so it stays as positive. Equal to 0. Now, we have the equations for the meshes, but we still need to define another thing of the supermesh: the interaction between the currents, how they relate to each one to other. So it's going to be it's going to be I3 minus I2 equal to 1/4 amperes. Why positive and the other one negative? Positive because the proposal that we are stating here goes in parallel with the one that the source is giving us. In this case, the 2 is going down. So this one is going in the opposite direction of the other one. So we're going to be working with that one. And well, here we have a system of equations that we can solve with different ways, in different forms. We'll be working with an external A. So, using an external calculator, we solve the system of equations. The system of equations was stated that it was going to give us the solution for each one of the currents. Now, what are we going to do with those numbers? We need to solve for the x. So, the x is going to be solved through Ohm's law. In this case, Ohm's law states that voltage equals to R times current. So, in this case, it's easy to know that we need to work with this current, that is 45 ohms times the currents that are dealing with the branch. So, here's the trick. In this case, we can see that the current, the loop, is behaving in this way. It enters the positive, it comes out negative. So this is going to be our positive. And in this case, the I2 comes for negative and comes for positive. So it is going to be stated as a negative sign. So already stating this, we can solve for Bx. A little plus. So we have 3.14516. And well, this will be volts. That is going to be our value for Bx. Now, with the power of this source, this is going to be through another formula that is power equals to voltage times E. So in this case, the voltage is a really tricky one because we need to get it through another branch that is not going to be this one. It's going to be this one instead, because these two branches are in parallel. This means that the voltage is going to behave the same in this branch and this other one. So we're going to have to get the value of the voltage in this resistance, which is resistance times current, which is 44 times I3. And we're going to use the calculator here. 0.74 10.6453 voltages. But this is not the answer yet. We need the power. So it is going to be V4 times I, which we're not going to be checking the power in this branch. We're going to be checking the power in this one. So the problem already tells us that it is the value of the current is 1/4 of an ampere. So we'll be working with that. 10.6453 times 1/4. And it's going to give us 2.66134. That is going to be our value for the power. This one is positive, so this means that it actually consumes energy from our circuit. Thank you very much.